the meetup. Today we're going to cover the second part of our AWS IoT overview, diving into AWS IoT Greengrass. And this is part of the meetup series of the AWS Meetup Group, a user group with AWS based out of the Denver area. And just a quick round of introductions. I am Kevin Tin, co-organizer of the meetup. I'm a cloud application architect and practice lead at Worldwide Technology, as well as an AWS community builder. My counterpart in the meetup, Austin Lovelace, the founder of the meetup, full stack developer and DevOps engineer at Stuzo, and an AWS community hero. And so to jump into the agenda for today, first we'll take a look at the overview of the service, the Greengrass service that is. We'll get into how to set up a device, in this case a Raspberry Pi, as well as the Greengrass service itself. Then we'll jump back into the Greengrass core setup on the Raspberry Pi. Then we'll start looking at how to use the Greengrass core unit, deploying a Lambda out to the Raspberry Pi itself. A lot of the constructs within Greengrass are based upon message queuing on premises, not within AWS, and we'll get into that a little bit more. So we'll kind of dive into what are the constructs of that message queuing using the MQTT service and how to use it, setting up subscriptions, stuff of that nature. Then we'll dive into kind of the difference in Greengrass of on-demand versus long-lived Lambdas. Again, getting into Greengrass services and connecting devices, how to configure devices. Then finally, we'll get into device shadows and a demo of device shadows. And so to just briefly cover the IoT Greengrass service, Greengrass provides an extension of AWS services to on-premises devices. And so some examples of this, not an extensive list, but including some examples would be Lambda, machine learning, message queuing, secrets management, and data streaming. And so the Greengrass service itself is optimized for IoT or Internet of Things use cases. Also, the provisioning and deployment capabilities are a big plus to the service itself. The ability to provide over-the-air updates to your Greengrass group, offline operating capabilities, and so the ability to have AWS services on premises even when internet connectivity has gone down, for example, as well as the built-in security of the service itself. And so I'll go ahead and jump out of the full screen mode here as I'm going to be jumping back and forth between windows pretty frequently here. So first of all, we'll get into the device setup. And so firstly, and I won't go into this explicitly as I've done this ahead of time, but Greengrass can run on a variety of platforms, ARM, x86, for example. And so for this, I'm using Raspberry Pi for my Greengrass node, and I'll just be interacting with it from my laptop across the local area network. And so to get started with this, you will need a Raspberry Pi, obviously. You'll need to format the SD card of the Raspberry Pi, and then you'll need to flash it with some sort of flashing software. So I use SD card formatter on my Mac for the formatting of the card, and then the Etcher software to go ahead and put the Raspbian Buster zip image on there. So just a quick overview of those. And you can download these pretty easily. And so the SD card formatter, very simple application. And then with Etcher, with this, you download the zip file, in this case, the 2020 213 Raspbian Buster zip image. Go ahead and select the file from there. If you have a card inserted into your card reader on your computer, you can select the target there and go ahead and flash it. It also provides the ability to flash from a URL as well. And then also, finally, the ability to continue to clone devices if you want to create, say, multiple SD cards with the same image. And so after you've gone through this, the flashing of the SD card with the Raspbian Buster image, go ahead and insert that into your Raspberry Pi, boot the device up, and go through the config. And so the config on the Raspberry Pi, you will need a keyboard, a mouse, and a display connected, and it goes through, selecting the default language for the operating system, setting up Wi-Fi, etc. Okay, and so once you get this on the network and enable SSH, you'll be able to interact with it. And so at this point, let's go ahead and say that you've configured your Raspberry Pi to get on the network, um, and you are getting into enabling SSH. In order to do that on the device, you'll need to go into the raspi config. And so we can emulate this. Um, let's see. So you'll need to sudo raspi config here. That pulls up a window that looks like this on the Raspberry Pi. And if you want to get into, for example, changing your host name, you can do that here. Um, but what you will have to do with the keyboard, mouse, and display still hooked into the Raspberry Pi is enable SSH. And so to do that, you'll have to get into the interfacing options and enable SSH. I've already done this, and so I'll just kind of breeze through this. Okay, and so additionally, you can go in and change the host name of your device. As I had mentioned, I use GG, which is short for Greengrass, and I'll use that abbreviation pretty frequently here. And so in order to kind of confirm that, the command host name will pull back the host name GG as expected. And then also, you will need to get the IP address of your Raspberry Pi. And so in order to do that, it's as simple as the same hostname command, but -i for IP address. And that gives me 192.168.1.130, as well as the IP v6 address, which we won't be using in this case. After you do all of this, you will need to reboot the device, and these changes will take effect, and then you'll be able to SSH into the device. And so some basic setup that you'll have to go through in order to set up the Greengrass Raspberry Pi is you'll have to add the default Greengrass-Core user and group. So GG, short abbreviation for Greengrass. GGC, that's abbreviation for Greengrass-Core. So I've already done these steps. And so with that being the case, I did want to just outline the setup that I went through. So adding the user and the group, it's also recommended that you harden the device with symbolic link protection, symlink protection for short. And so inside of the etc syscontrol.d file, the fs protected hard links equal 1 or true, and fs protected symlinks equal 1 or true should be set up. And then you'll need to reboot after that. After that, the memory limits need to be set up. So going into the boot directory, and then there's a command line.txt file, and then adding the memory C group underscore memory equal 1 to the end of that. And again, you'll need to reboot. And if your system, for the purposes of these examples, does not have Python 3.7 installed, you'll want to also install that. And additionally, if you get into wanting to get into the streams management portion of Greengrass, you'll also want to go ahead and install the Java 8 runtime. That's not applicable for today's demonstration. Okay, so now we get into some of the more fun stuff. So you'll want to go ahead and get the required dependencies. And so with that, we've got these commands here to make a directory and download the dependency checker for Greengrass-Core. And so with that being the case, let's go ahead and pull this up here. And we can pull the console down below it. And so with that being the case, so we will go into cd home pi downloads. Let me make this a little bit bigger. I'm sure that's hard to read. Let's see. All right, so here I've already created the directory for the dependency checker. So here I can get into that. Taking a look here, The next trick is to go ahead and do a wget and download the dependency checker and then unzip it. Again, I've already done this. So then you can just go ahead and get into that directory that came from the zip file. So let's go ahead and get into here. And so this pulls back a bunch of different files that came out of the zip itself. So with that being the case, I'll skip to this last step just to show you what the dependency check looks like. And so here, it goes through and it checks the kernel architecture to ensure that that is something that it can operate on, the kernel version. It also gets into the various um, commands and software packages that you have installed. So for the purposes of our demo, Python 3.7 is the most pertinent, um, as well as some things such as like wget to download the software, tar to go ahead and be able to unpackage archives, things of that nature. And again, it checks the security, so where we went ahead and set up the hard link protection and symlink protection, it checks on that. And then finally, the default user and group, it will check on that. And so it does mention Python 3.8 not being supported. And then also it'll get into some other things. Like, for example, I mentioned Java 8 not being there. It will mention that you're missing a few other things if you just go with this base setup here. Okay, and so now to get into setting up the actual Greengrass service itself, um, now we'll jump over to the AWS portal. And so once we go there, we'll go ahead and create our Greengrass group. This is basically the core management container for everything that we're going to do going forward. And so to get into that, let me go ahead and log into the console. If you do not have multi-factor authentication set up for your account, I would strongly recommend that you do so. Okay, so inside of the console, this is located within IoT, so the IoT Core is a good way to get there. Looks like this is taking a few seconds. Let's go ahead and switch back over to the slides and take a look at the steps we're going to go through. And so during this process, we're going to go ahead and create the Greengrass group as well as the Greengrass-Core device. I've already done these things, but I wanted to spell these out as the steps that you want to take. So for the purposes of this demo, they have a new UI, and so I've not gotten ultra familiar with it. I tend to operate just from the classic or V1 version of the UI, and so you'll want to navigate into groups here. So I've already created my group, but to get into creating your group, obviously you'll want to hit the create group button. The just for most use cases, just go ahead and create the default creation. We'll give this a name. Then after that, we'll go into creating the Greengrass-Core. That's the kind of the control of the whole Greengrass group. And you can have multiple cores, but in this case, we're just going to have a single. And the Greengrass-Core in this case is going to be the Raspberry Pi that we walk through the configuration for. And so once we get into this, we get into what will be done on your behalf, and then the creation of the group itself. So it walks through the steps that it tells you that it's going to walk through. And then finally, and this is incredibly important, you'll want to download the resources here, your certificates, and this is incredibly critical in order to ensure the security of the Greengrass group itself. And so jumping back into the slides, I have a little screenshot here. Don't forget to grab the certs. So with that being said, jumping into the the next step here. At this point, what you'll want to do is go ahead and download the files. Um, then you'll want to do a secure copy of the files over into the Raspberry Pi. And so from the initial setup, when we did the hostname-i, you'll get the IP address, and then also additionally, there is a Greengrass-Core runtime, and so that's easy enough to find for your particular architecture. So that's in this particular case. Let's see here. To copy over the certificates, and the actual runtime for Greengrass was the Linux ARM 6L1.11. And so if you're running on a Raspberry Pi, easy enough to go out and find the download of that. So fair enough. With all that being said, you can also go into the AWS docs to find your platform here. So where I have the Raspbian distribution for my Raspberry Pi, I just went ahead and grabbed it from here. So at that point, you'll, like as I mentioned, want to go ahead and secure copy. SCP stands for secure copy. This is available on Mac and Linux like operating systems. With a Windows operating system, you'll want to use a utility such as PuTTY. And so going ahead and getting these securely copied over to your Raspberry Pi in the home/pi directory will be what you'll want to do. And then on the device itself, you'll want to run these commands to go ahead and extract the contents of your zip files into the root and then into a Greengrass folder. And so get into here and into the home of the user. So here we went ahead and this is where we uploaded the executable for Greengrass, as well as the certificates as well. And so with that being the case, we've got the Greengrass directory here. And so to get into the file system here, we have a search directory, a config directory, the Greengrass-Core directory, and the OTA directory. And so the search directory is of particular importance. So let's go ahead and dive into that. So after following the steps, we would have these three certificate files from the zip that we downloaded from the core device configuration. And so with that being said, there's still a root certificate authority file that you will need in order to get Greengrass to run. With that being the case, get into that search directory inside of the Greengrass directory, as I mentioned, and just run the command sudo wget the root CA from the AWS path that's specified. And so that you can find that as well from this choose root CA. And so that's actually this file right here, if I'm not mistaken. So for most use cases, you'll want to go ahead and use the root certificate authority 1. And so why all the business with these certs? As I mentioned, Greengrass is a security first kind of platform. And so everything is basically secured using certificates. So from a device standpoint, that includes the Greengrass-Core device, as well as IoT devices that we will create here in just a little bit. And so the next step here is to go ahead and start up the Greengrass daemon. And so in order to do that, we'll have to get into Greengrass ggc/core. So let's go ahead and start that up. One more. Okay. Actually, I went too far. Bear with me. Uh, let's go ahead and just copy and paste here. Okay, so here we've got the actual daemon itself. And so to start it, it's as simple as sudo superuser do is what that stands for. Greengrass-D, the daemon itself, and then start. And then it'll output a process ID. I did this earlier. We can do this again for sure. And so since it's already running, what this is going to do is stop the daemon and then restart it. Uh, Worth noting that if you restart the device that it's running on, the daemon by default does not run itself, and so you'll want to configure the device to start this up in a production scenario on device startup. And so with that being the case, we've got this process ID that it outputs of 8123. And so if we want to dive in and take a look at just the process information on that, we can use the ps aux command and then use that process ID that it outputted. And so here we can see that this is running. It's not been running for long. I just restarted it. I think that's to be expected. But we do have it running, so that's very important. So with that being said, an interesting title, a happy dog, we've uh, we've got half the battle. And so now the what we want to get into is with the runtime itself going. We want to go ahead and actually get software running out on the Greengrass-Core node. And so in order to do that, the easiest way to deal with that is to use the familiar Lambda programming model and then deploy that out to our Greengrass device. And so I will say that a lot of the examples coming out of this presentation are just coming out of the SDK. And so the SDK comes for a variety of languages. I'm using Python in this case, but Node.js, Java, and C are available. And so I've downloaded this, and I'll just go ahead and open up Sublime, and we can take a look at this. And so what you'll get is the core SDK here. Uh, as for any good software, comes with documentation that you can dive into, and then a bunch of examples. So a lot of this will be driven from the examples that are provided to us from the SDK. And so just for the purposes of our first deployment of working software, we'll just do the hello world. So in order to get into that, the steps are to get into the hello world directory, and then you'll need to actually copy the SDK into the local directory. One second, please. So what that looks like is here within the examples, we have hello world, but we do actually, we're going to package this up into a zip file and create a Lambda inside of the console with that. So we do actually need the proper Greengrass SDK to be packaged up with our Lambda code as well. And so this is a very simple example that all it's going to do is once it connects, it's just going to publish to a hello world topic, um, and it's going to say hello world sent from, and it's going to specify the platform that it is sent from. And so with that being the case, this looks like once the SDK is copied into that hello world example, going out and zipping up the Lambda itself, um, as well as the SDK folder, and we'll put that into a hello world python lambda.zip file. And so with that being the case, I went ahead and did this ahead of time. If you run that command, the hello world python lambda zip file is created. And also something that I want to point out, if you want more verbose instructions, This is all available from the Greengrass tutorial, and you can find that by simply going out and searching for Greengrass tutorial, and this will go through these steps in more detail. So definitely go out and check this out if you want to get some hands-on experience with the service. So at this point, we are into uh, module number 3, and so this should look pretty familiar. And so the play here is, now that we have the zip file, we want to go ahead and create the Lambda itself. And so uh, let's jump into the Lambda service. And so the first step to this is to create a Lambda. And so there's nothing special here. This is like any other standard Lambda. The create function is where you want to go if you haven't done this before. Again, very verbose instructions within the tutorial itself. I went ahead and set this up ahead of time for the purpose of for the purposes of time. And so with that being the case, if you want to go ahead and configure this, you'll want to upload from the zip file that you just created. And then additionally, you will want to get in here and configure the runtime to Python 3.7, as well as the handler that is basically the entry point into the code when the Lambda is invoked. And this Greengrass hello world function underscore handler, that actually comes from the code itself, where we have Greengrass hello world. So with that being the case, we now have the Lambda itself configured. And the next step is to create and this is optional, but this is recommended, create an alias. And so once we get into creating the alias, I went ahead and gave it the name gg underscore hello world, and then I pointed to a version. So if we want to get into what the configuration of this looks like, you just give it a name and a version. So let me actually back up a sec. And so you name it, and then you can give it the tag latest will just be the most recently published version of the Lambda, or you can have an explicit version itself. And so what the alias does is, when you start to configure that within your Greengrass group, you point to the alias and not a specific version. And this allows you to, behind the scenes, update the Lambda without having to need to actually update the configuration of the Lambda and its inclusion within the Greengrass group. And I'll get into that in just a second. So diving back into these slides, we give it the alias, and then we go ahead and add it to the group. So diving back into the Greengrass group itself, to add the Lambda to the Greengrass group, you want to get into the group, and I'll just go ahead and go with the group that I've already configured. And so here you have the Lambda's submenu option. You'll want to dive into that and then hit add Lambda. And so since we've already defined the Lambda, we go into use existing, and these should look familiar. We've got Greengrass hello world, and then you can configure this to point to a specific version, or you can configure it to point to the alias. And since we can use the alias as a bit of indirection to be able to maintain and configure and update versions behind the scene, it is recommended that you point to an alias itself. So that being the case, we'll jump back and back and back one more time. And so at this point, we need to go ahead and set up what's called subscriptions. And so this is a pretty core element of Greengrass itself. And so what we'll want to do is configure the Hello World Greengrass subscription. So to dive into what this looks like, we'll select a source and a target. And so what we'll want to do is, from the Lambda that's deployed to the Greengrass-Core node, we'll want to send that out to the IoT cloud here. And so once you select the source and the target, the topic is just hello and world. So this has already been configured. So I'm going to jump back over into the group, and the next step is to actually deploy out to the device. And so this is pretty cool. So here we can jump into the group itself and go ahead and let's see here, and actually deploy the configured software. And so here at the core of the group, hit the actions and hit deploy. And so what this will do is actually deploy the Lambda as well as the description out to, or the subscription out to the device. And so once this has completed, if you want to test the communications itself, we can get into the MQTT test client. And so here, if we want to check out what's going on the topic itself, we'll have hello world test, and the Lambda itself is going to run every 25 seconds. So we'll wait a little while for this to come across the air. So let's jump into this. Interesting. Since we are dealing with a demo, of course we get the demo bugs. Sometimes it just is like that. Let's go ahead and give this a subscript. Let's go ahead and attempt to deploy this again. On deployment, it will tell you that it's started the deployment itself, and you'll see that it's pending out here. It'll tell you that it's in progress. And this usually happens pretty quickly unless the device itself is not up and running. And so we have completed the deployment. So this is pretty cool. Definitely worth pointing out that by just a few clicks in the portal, we've sent software out to the Raspberry Pi itself, and it is up and running. And so I'm not sure what's going on, to be honest with you, but we're having some demo bugs. Let's take a quick look at the configuration. And so in here, we've got a 25-second timeout on the Lambda. If you're familiar with Lambda, you'll understand that this is the how long this can run for before it times out. And then there's also the option to configure this as an on-demand Lambda, which would be triggered from a subscription within Greengrass, or to make it a long-lived Lambda that keeps running indefinitely on the device. Let's see here. I think I have an idea what's going on. I think I may be paying attention to the wrong topic. Okay, yep, I think that's what's going on. So, like a goof, I got the wrong subscription. So, all right, so we've successfully troubleshooted this. So now we're seeing the messages coming from the Greengrass-Core device itself. Okay, so let's dive back into the slides. And so at this point, we have created the Lambda. We added it to the Greengrass group. We went ahead and deployed it over the air to the Greengrass Pi. And then we also went ahead and set up a subscription from that Lambda to the IoT Cloud, or AWS, on the hello/world topic. We have seen this as well. So we've seen communications from the device. So this is all pretty cool, but it's just a basic hello world use case. And so now that we've kind of seen the software in action, I do want to dive into a very core aspect of the platform itself, of the service itself, and that is the message queuing telemetry transport, or MQTT. And so this is a TCP-based, TCP/IP protocol-based messaging standard that's been intended and optimized for IoT, or the Internet of Things. It provides a pub/sub architecture, and so that you can provide the many-to-many communications that drive an event-driven architecture. It's very lightweight and efficient. It is bidirectional, so the data can be sent from the device to AWS, or from AWS to the device, or from a device to another device. It is secure. We've got the certificates in place, as we've seen. And then it's also reliable on unreliable networks. If the internet connection goes down in your on-prem network, you still got these topics being maintained by the Greengrass-Core node itself. And so also just a quick note on the on-demand versus long-lived Lambdas. Um, we took a look at it in the console. Greengrass offers the on-demand or long-lived options there. And so to kind of dive into why that would be important, let's take a look at a code example. And so another example that's provided in the examples, another sample provided in the examples, is the Greengrass counter. And so here, standard to Lambda, we have the function handler itself, but it also has, outside of the function handler, a counter. And so every time that it is invoked, the counter is incremented by 1, and then this message is sent out to AWS on the Hello World counter topic. And I'm not going to set this up for the purpose of time, but in the scenario that a function is on demand, this counter variable is always initialized and set to 0, and then incremented and sent over. So every time it is equal to 1. And so if it's long lived, the state, the counter is maintained, and then say the second time that the Lambda is invoked, this counter itself will be equal to 2. So this allows you to keep some level of state within your Lambda that's running on the Greengrass-Core node. Okay, and so we touched on subscriptions pretty briefly, but I do want to dive back into the portal and kind of show you some of the options there. And so diving into the group, we can dive into subscriptions, and then just to kind of show off the possibilities, the add subscription option here. And so here we went from a source of the Hello World Lambda to a target of IoT Cloud. So we send this out to AWS. But we have other options as well. And so we could have that Lambda that's running in a long-lived manner, and it could send messages out to a device that we set up. And so that gives us some options in terms of where messages come from and go to. And so another, and we're not going to get too far into this for the purposes of time today, but another option here is a connector. And so the Lambda could send to a connector that then dumps data into, say, a database, for example. And so this allows you to source events from, say, like a database, use an MQTT topic, and send it to, say, a device or a Lambda running on the Greengrass-Core node itself. And so these subscriptions are pretty powerful in a core aspect of the service. Okay. And so let's go ahead and dive into devices. And so as we can see from the diagram here, we've got AWS IoT Core, and we've worked a little bit with uh, the Greengrass-Core node itself. But what about in the Internet of Things, the things themselves? And so we have the publisher device as well as the subscriber device in this diagram. And so this allows one device to interact with another device via the Greengrass-Core node, and this is done again over the MQTT protocol. And so one of the powerful things with the service itself is the devices do not need to know the specifics of the other devices. For example, the IP address of the subscriber is not known to the publisher as the message queuing protocol is used. And so the subscriber simply subscribes to the queue name that the publisher is publishing to. And then that way it basically doesn't have to know the specifics of the publisher itself. Okay, and so the basic example from the tutorial is that publisher and subscriber. I'm not going to get into actually deploying this. We have a more advanced device use case a little bit later, but we can take a quick look at the code, and we'll increase the size of this. And so in the tutorial, they get into a publisher and a subscriber in order to create the devices. And this goes into the security first design of the service itself. We can go out and create devices. And so within the group itself, there's a devices submenu. And so this is to create a new device is where this will take you. You'll name it, and as we saw with the Greengrass-Core node setup, it'll give you a whole bunch of certificates files that you'll need to get onto the device. And so with that being the case, once this is configured, um, let's go into the publisher. They have a basic discovery service here that takes the endpoint of your Greengrass cluster, the files from the certificates, a name, a topic, and a mode, and this simply goes out and if you run in the publisher mode, it will put messages onto the topic, and if you run in the subscriber mode, it'll pick up messages off of the topic. And so this is pretty straightforward and a pretty basic use case. But if you go through the tutorial, this is where they will take you to begin with, just to get the basic fundamentals of a device within Greengrass. And so to dive into a more complex subject within devices, Greengrass has the concept of a device shadow. And so a device shadow is basically the state of a device, and this allows other devices to manipulate a device without having to connect to it directly. And so we'll get into a use case here in which the uh, IoT shadow is used to drive the color of a traffic light. And there's an actual device, the traffic light controller, that tells the traffic light when to change. And since the traffic light device pays attention to the traffic light IoT shadow, um, when the traffic light controller sends a message to the IoT shadow to change the state of the traffic light will pick up that change and then change its state itself. And so to dive into this, let's go ahead and jump into the next slide. So what we have done out in the portal, again, going into the Greengrass group itself and jumping into the devices, went ahead and set up a GG switch device. And so in this, we just went ahead and followed the setup for the device. So let's go ahead and just kind of jump into what that looks like. So there's an advanced setup as well as a one-click setup. Would recommend just using the one-click setup just for these kind of basic tutorials and basic use cases. And so here, similar to the Greengrass-Core node setup, it'll go ahead and give you a set of certificate files. You'll want to download these as well as the certificate authority. And so the setup of the devices in the meetup group was done for both the Greengrass switch as well as the traffic light itself. And so the additional step here is to set up a shadow for the device, which represents the desired state of the device. And so that's as simple as jumping in and creating a shadow. And so there's the ability to create the classic unnamed shadow or a named shadow. And so with the named shadows, which is a fairly new feature, this gives you the ability to have multiple states for a single device. And so I think that's more of an advanced use case. We'll kind of leave that alone for today, but I did want to let you know that that feature is available. And so to dive into the use case here around the traffic light controller, setting the state of the traffic light via the IoT shadow, let's go ahead and dive into some code. And so again, this comes out of the examples from the SDK. So we have the traffic light and the traffic light controller. So let's dive into firstly the traffic light itself. And so here went ahead and got the device certificate files and added them to the local directory with this traffic light.py file. And so we'll get back into the callback here, but what happens when the device, in this case the simulated device, starts up is it goes out and it discovers the Greengrass-Core node. And so to kind of put a picture to that, upon startup of the script, the device goes out and hits the IoT Core group and gets the information about the Greengrass-Core device that is on the local area network. And so this example here goes ahead and gets the certificate paths, and then it'll go out and hit the discover method from the SDK, talk to AWS, and figure out how to talk to the Greengrass-Core node. And so once it successfully connects to AWS, it'll get the connectivity info list, and then inside of that is a set of addresses. And so we saw on the, let's see here. So registered within the connectivity infos is the IP address of the Greengrass-Core device itself, the IPv4. Then also the IPv6 address is also registered, and another address that's registered within that connectivity list is the localhost loopback 127.0.0.1. An important note, if you walk through the tutorial and you use a device that's, let's say you use the Raspberry Pi for your Greengrass-Core, and then in this case, I'm using just my local laptop for the simulated traffic devices. The first address that I found that it was coming back with is 127.0.0.1. And so, just a gotcha I want to warn you about is when I tried to run this the first time, the first address that came back that they have this is IP address. This is specific to v4. Jumping into here, it's going to look for the 4 octets that make up an IP address. The first one that came back was the localhost loopback, and so that didn't work because I'm running the Greengrass-Core node on Raspberry Pi, which is not my local laptop, so I ended up having to modify the script itself to say I don't want it to use 127.0.0.1. Okay, so once we get the connectivity information, the script itself will go ahead and just print that out. It'll go ahead and configure the certificate information. If it can't discover the device, it'll go ahead and fail. And then at that point, it'll go ahead and connect into the Greengrass-Core device, and then it'll start working with the device shadow. And so here, this is the traffic light itself. And so this simply waits for updates to the device shadow. So those actually come from the light controller. And so very similar here. It will come up and perform discovery. You'll have to add the logic to omit 127.0.0.1 here. Then it'll go through all the authentication and discovery. And then the important thing to note here is at the end that what it's going to do is it's going to wait, I believe, 20 seconds here, and it's going to go ahead and produce a new device shadow update. So this is going to update the desired state of the traffic light itself. And what it's simply doing is from the different states, green, yellow, red, it's just going to cycle through these. And so this is just a cycle. So this for loop runs indefinitely. And so it will just go ahead and produce the next state onto the topic that updates the device shadow. And then it sleeps for 20 seconds. So to see that in action, let's go ahead, switch back over to the command line. And so what I've got here is I've got the traffic light. And so I'll go ahead and run the traffic light Python script here, specifying the IoT endpoint for my Greengrass group. I will specify the certificates as well here. Specify a thing name of GG traffic light, as well as a client ID of GG traffic light. So we'll go ahead and start this up. Okay, so everything goes well. It just tells you that it's subscribed to the Delta topic for the device shadows for the GG traffic light device name. Another got you I will warn you about that if you run this on one network and it discovers the Greengrass-Core host, it writes out this file with the IP address of that host. If you switch up the host IP address for some reason, say that you take your Raspberry Pi and you put it onto a new network, then it will have difficulty connecting to that device. And in order to fix that, you'll just want to delete this group CA folder, and that remedies that issue. Okay, so now that we have the traffic light simulator running, we want to go ahead and get the controller running as well. And so again, if you're switching networks, a new IP address, you'll definitely want to delete the group CA directory before you run the traffic light or traffic light switch simulator again. And so with that being the case, now we've got the traffic light controller up and running, and we've got the subscribe Delta topic over here. And so at this point, pretty soon, okay, so the controller itself, after it waited 20 seconds, went ahead and produced a message for the device shadow, the intended state of the traffic light itself, to go ahead and turn into yellow. And so over here, as the device itself was waiting and listening to updates for the device shadow, it picks up the change to the device shadow and changes to the desired state. We just produced a new message with red as the desired state. And so at this point, the traffic light simulator has changed its state to be R, which is to simulate red. And again, we see it cycle back into green after 20 more seconds. And so that gives us the very simple use case of one application modifying this, or sorry, one device modifying the state of another device by interacting with the device's IoT shadow. And so the use cases are pretty powerful here when you start to talk about real world IoT use cases. If you tuned into the IoT part one, um, meetup, we showed a simulation of kind of a sensor network in which the pressure and temperature were being read. And so, say this is more of like an industrial use case where you have a sensor that's picking up on temperature and pressure in some sort of manufacturing process. If you have this device that's looking at those sensor readings and says that, we don't want the pressure to be above a certain number, and please shut it down once you get above a certain threshold. This would be a way to go ahead and make that possible in more of an industrial type of use case. And so that brings us to the end of the demo for today's presentation. And so I do want to cover some of the available advanced topics that are out there with Greengrass. Greengrass does give you the ability to keep your secrets locally on the Greengrass core. And so to do secrets management locally without having to connect to AWS. If you have a lot of devices, there's a group management feature there. If you want to do machine learning at the edge, Greengrass also supports that. They have security intrusion detection. I've added a link to the pricing here, as well as a stream management component of Greengrass. And so thank you for tuning in. That concludes the presentation. I'll stay on the stream for a few minutes to see if there's any questions. And if not, I hope you all have a good evening. Looks like we have no questions on the stream. So